Hey guys, welcome back to the LearnAPChem series. In this video, we're going to talk about a basic overview of reactions. So, how chemical equations are written, balancing chemical equations, reaction types, so combustion, single replacement, double replacement, neutralization reaction, synthesis, decomposition, and oxidation reduction. We're also going to talk about net ionic equations and half reaction equations. Be sure to leave a comment if you're confused or have questions, or you can ask in the weekly live streams we do every Sunday from 5 to 6 p.m. Eastern. So without further ado, we'll get started. Alright, so let's talk about how chemical equations are written. Chemical equations are written like so. So we have reactants, a chemical reaction happens, and these become our products. So for example, I've written out the combustion of hydrogen gas and oxygen gas to become water. So we have our reactants here, two molecules of hydrogen gas, one molecule of oxygen gas. They undergo a reaction, and then they become the product, which is two molecules of water. So again, reactants, reaction, products. Alright, now let's talk about balancing chemical equations. Chemical equations must be balanced, meaning that the number of each type of atom of the reactants should equal that of the products. So again, here I've written out the combustion of hydrogen gas and oxygen gas to become water. And you can see that in this equation, the reactants contain 4 atoms of hydrogen. So here are reactants. We have 2, which is our coefficient, multiplied by our subscript. 2 times 2, 4. So we have 4 atoms of hydrogen. Here we have 2 of oxygen. So if you don't see any coefficient, you can just assume it's 1. 1 times 2 equals 2. Now we can see that the same is true of the products here. In our water molecule, we have 2 of them. Multiplying that by the hydrogen coefficient, we can see that we have 4 atoms of hydrogen, the same of the reactants. We can also do the same for oxygen and see that it's the same. So therefore, since we have that the same number of each type of atom in the reactants being equal to that of the products, we can say that this chemical reaction is balanced. Now do note that you should never change the subscripts. You're only messing with the coefficients or the number of molecules in the reaction. So if we had, say, this here, and you wanted to balance it, one thing you couldn't do would be like rewrite this as O1. Don't do that. You only want to be changing the coefficients. You should also make the coefficients whole numbers. So you wouldn't want to write this as like 1/2, 1/2 or something like that. And then finally, you want to use the lowest factor. So if I had like 4, 2, and 4, you would want to simplify that to 2, 1, and 2. Alright, so let's do a quick couple of practice problems. So balance the following chemical reactions. So pause your video, unpause when you think you found the answer. Alright, so let's walk through these. So for this first one, I can see that I have 4 oxygens, 2 plus 2 equals 4, and 3 on this side. So I'm not really going to be able to get to 3 because these are greater than, and this number is odd, and these two will always be even. So let's start by multiplying SO3 times 2. So now I have 6 oxygens. And here I have 4 oxygens. Now what I can do here is I can try to balance these. So if I multiply this by 2, I can see that I'm left with 6 oxygens now. 2 times 2 is 4 plus 2 equals 6. So the oxygens are balanced. Now I also have 2 sulfurs here, and I've balanced that out by multiplying this SO2 by 2. And so thus I can say that this first one is balanced. Alright, so let's look at the second one. So here, if I just take quick stock, I have 1 magnesium on the left, so I'll say, or I'll make it more specific, reactants. And here we'll have products. So I have 1 magnesium in the reactants, 1 for our products. In the reactants we have 1 hydrogen, 1 hydrogen and 1 chlorine. And in our products we have 2 hydrogens and 2 chlorines. So here it's fairly obvious what we should do. If I balance either chlorine or hydrogen in the reactants by multiplying by 2, I'll inevitably balance the other one. So here now I'm left with 2 hydrogens and 2 chlorines. And so here I can say that this is balanced because all of these are equal. Again, guys, if you have any questions, be sure to leave a comment and I will help you out with this. Alright, so let's look at our final one. We've got methane gas combining with oxygen to produce carbon dioxide and water. So here, again, if I take stock of our reactants and our products, I can see that here I've got 1 carbon in the reactants, 4 hydrogens, and 2 oxygens. And in the products, I have 1 carbon as well. Make that a little more clear. 1 carbon, 3 oxygens. I have 2 here and 1 here, and 2 hydrogens. So I can see that oxygen and hydrogen are not balanced. So let's start by trying to balance the hydrogens first. So I want 4 here in the products. So if I multiply this by 2, let's retake stock. I've got 4 hydrogens, and now I've got 4 oxygens. I have 2 here, and then 2 here. Now we can see that this is a problem because oxygen still isn't balanced. There's 2 in the reactants, 4 in the products. So I want more here. I need 2 more, so I'll just multiply this by 2. I can now see that I have 4 oxygens in the reactants. And so if we look here, this is now balanced. Alright, so let's talk about types of reactions. You're not going to have to memorize these definitions, but definitely be familiar with these different types that I list and sort of what they mean. Do note that sort of as you continue along in AP Chemistry this year, you'll learn these terms better, so it's not really worth it right now to be trying to memorize these definitions. That being said, let's jump in. So our first type of reaction is combustion, and this is where a carbon-containing compound combusts with oxygen to form carbon dioxide and water. So I saw up here that I have an example. I have a carbon-containing compound combining with oxygen to form carbon dioxide and water. So this would be a combustion reaction. Alright, so now let's talk about single replacement reactions. So an element reacts with a compound whereby a new element is formed and a new compound is created. So I have an element here reacting with a compound whereby a new element is being formed and a new compound is created. So I have this element aluminum reacting with the compound, creating a new element, which here is iron, and creating a new compound. So original element, original compound, new element, new compound. So that's a single replacement reaction. Double replacement reaction, this is where 2 compounds react in the cation switch. We also have a neutralization reaction where an acid and a base react to form a salt in the water. might not know what that is, acid and base. We're going to talk about this in much greater detail, so don't really worry about that for now. Synthesis reaction, two elements react to form one. So this would be, like I talked about earlier, hydrogen gas, oxygen gas, reacting to become water. The opposite would be a decomposition reaction, so one element decomposing to form two. And then an oxidation-reduction reaction. One element loses electrons while the other gains. And I'm going to talk about that in greater detail in a second. Alright, so as promised, let's talk more about oxidation-reduction reactions. So one compound in the formula is losing electrons while the other is gaining. So we can write these fully like below. So we have iodine here with two iron 2+, so an iron ion. And then our iron is losing electrons, so that's why it's 3+. We're losing one electron from each iron, and these are going to the iodine and making it negative. So again here, this iodine is stealing one electron from our iron, and then so here we have 3+ now because it lost an electron, and our iodine is now -1 because each iodine gained an electron. Now these can also be written in what are called half equations, where you only write out one element in the gain or loss of electrons. So as I said earlier, each iodine is taking one electron. So I write down my I2 plus 2E-, simply meaning 2 electrons, and this combines to form 2 negative iodine ions. Similarly, I can write out my iron losing an electron. Fe2+ becomes Fe3+ plus an electron. So this is what half equation would look like. Again, if you have any questions about that, don't hesitate to leave a comment. Now, sometimes you'll be asked to balance half reactions, where essentially you have to add these two together and then balance them. Now, this is very similar to balancing chemical equations, but the key here is that there should be no electrons in the final formula. So let's take a look at what this would look like here. Alright, so what you're going to want to do first is that ensure that these half reactions, when you add them together, will cancel the electrons. So we should have equal electrons on both the products and the reactants. So here in our reactants we have electrons. In this first equation we have 2. In the products of our second one, I only have 1 electron. And that's not going to cancel if I add them together. So I'm going to multiply this first equation by 2. And now that I can see that if I added this together, they would cancel out. So to add this together, I simply just write out my products from both. Reactants is what I'm doing now. And then I'll write the products from both. So here 2I- plus 2Fe, 3+ plus 2E-. And I can see here that I can cancel these electrons, and I'm left with the same equation that's up here. So that's how you would balance a half reaction. You have to make sure that when you add the equations together that the electrons will cancel out. Alright, so let's talk about net ionic equations now. When two ionic compounds react in an aqueous solution, only one cation and one anion will react to form a precipitate. So the compounds that are not participating are called the spectator ions. And just note that aqueous solutions are denoted by the AQ symbol. So in our first equation here we have AgNO3 aqueous plus KCl aqueous yields AgCl(S), which means solid. You might also see this, and these both mean that this is becoming a precipitate, and KNO3 aqueous. And so a net ionic equation is simply this equation written without the spectator ions. So I can see here that K plus and NO3 minus are both spectator ions, so they're remaining aqueous. So all I want to do to write the net ionic equation is write it without this. So I'm going to cancel out my K plus, and I'll just be left with Cl minus. And then I'll cancel out my NO3 minus, and I'm just left with Ag plus, and you can see that right here. Now you might also be asked to write the total ionic equation, where you'll just be writing out the ions in the equation. So what this would look like here is I would write just the ions, Ag plus Aq plus NO3 minus Aq plus K. Let me get rid of this, that might confuse. K plus Aq plus Cl minus Aq yields AgCl, precipitate plus K plus Aq plus NO3 minus Aq. Now you might be wondering why I didn't write these separately. Well, note that in an aqueous solution, ionic compounds can split into their ions. So all these AQs here can be split out according to their ions, which I've done here in this total ionic equation. However, our precipitate does not, so I have to continue to write that as AgCl. And then again, you might see this down arrow, or you might see S, and these mean the same thing. Alright, so that brings me to today's challenge problem. Balance the following chemical equation. CO2 plus H2O yields C6H12O6 plus O2. The solution to this is on our website, LearnAPChem, and I'll also include a direct link in the description. If you found this video helpful, please like and be sure to subscribe for future content, like us on Facebook, and follow us on Twitter for updates about our new videos and live streams, which we do every Sunday, where we answer your questions about AP Chem, and those will be from 5 to 6 p.m. Eastern. Links for that will also be in the description. If you're looking for other resources to help you learn AP Chem, be sure to check out our resource recommendation video. A link for that will be in the description as well. Leave a comment if you're still confused about anything, or also any other comments on the video in general. Other than that, I want to thank you guys for watching, and I'll see you in the next video.